Hey everybody, welcome to Bar Z. My name's Stan, and today we're going to be trying a new tool that I bought. This is something I bought up at Chuck Bomarito's open house. It's called a Boremate, and it's made specifically for a Bridgeport or Bridgeport clone. And it's a pretty interesting piece, and I thought you guys might be interested in going over it, installing it, and using it. It's got this tool block that bolts on to this bottom slide. This bottom slide has a way that's connected to this hand wheel. So let's get it installed and see what it takes to install it, and then set up for using it. Well, the first thing you're going to discover when you're installing it is that it takes up quill space. Basically down here, it takes up, because it clamps to the end of the quill here, so it takes up quill space. And when you go to tighten, your drawbar is flush, and what you have to do is use a thin wall deep socket to get on, to even get on your drawbar. So that's the first thing you're going to notice. Is you have to tighten the drawbar completely before you clamp this to the quill. So that's the first step, is get your drawbar pulled up. You know, you clean your quill inside and out, clean your Boremate inside and out, and then tighten your drawbar all the way up. Okay, and with our drawbar tight, next thing you're going to notice is that it takes up a lot of real estate. You know, this is a bunch here. I've got the table all the way down, and I'm running out of space quick. No riser on the mill. So if you're going to be doing some tall work or something like that, a riser is going to be a must. So that's the second thing I noticed. Third thing, it's heavy. Your clock spring in here, when you release quill, this thing is a pig, and it's, well, I'd say it's a good, 40, 50 pounds hanging off the quill there. So if you're, you're going to have to always be conscious of releasing that quill lock so your tool doesn't fall down into the part, which bad things can happen when you do. Now I'll show you what this does. I'm going to crank this hand wheel. I want you to watch that slide down there. See how it's coming out there? So you can actually do this on the fly. You know, we can spin the machine up right now. And we can actually move this the radius, diameter, whatever, manually, which is pretty damn cool. You got a locking screw here, which locks the gib and everything. So pretty cool. All right. So we're just basically doing some fly cutting today, but you could bore with it too. You could bore and fly cut with it both. So basically, it's just a giant adjustable fly cutter if you need it to be. All right, let's run this thing a little more. Okay, well, I'm trying to get everything in the shot. I got a dial indicator set right against the boring head, and I've got a zeroed up here on the wheel, and I'm trying to determine whether this is radius reading or diameter reading, whether we're cutting the numbers in half or not. Let's see what we do. First of all, we're going to back off and make sure we hit zero on with the backlash. I'm sure there's backlash in it. So I'm going to turn the wheel and bring us up right to zero. I made myself a little witness mark there. And let me adjust the table and get us on zero on the dial indicator. Okay, back off, come back. Did not repeat. Try it again. Okay, so we repeated there. All right, so let's give it 10 thousandths on the dial. And it looks like we're about 5 thousandths on the indicator. Now we go to 20. I'm seeing about 9.5 there. Let's go to 30. That should be 15. It's showing light on the gauge. Here's 40. Still showing a little shy on the gauge. Let's go 50. Still light, showing about 24. So it's reading conservatively. If you're boring a hole, if you're doing an ID, that's a good thing. If you're doing an OD, that's not necessarily a good thing. There's 60, and we're at 29 on the gauge. Let's take it all the way to 100. I'm sorry about the camera refocusing. 49. So it's about 1,000th conservative on the diameter. So it is direct reading. This dial will read your actual bore size. All right, but you have to. It's all cause and effect. You know, when you feed 10 thousandths, are you getting 10 thousandths? That's what you need to know. You have no idea. All right, so that's pretty interesting. It was just fun to check that out. And let's see if we come back to 0. Go past, take out our backlash. See if we come back to 0, which we do. All right, let's see if it repeats on the full scale again. Let's go 1 full rev. I'm seeing 49 down there. Let's go 2 full revs. See there, I'm 2 thousandths off. So full scale accuracy is going to get worse and worse as time progresses. Let's go 3 full revs. Yeah, see there, I'm 3 thousandths off. So for every full turn here, you're going to get about a 1,000th error in your diameter. So you need to check your parts often. Still pretty cool to be able to work your finish. You know, if your face like fly cutting, you can do like a radial where you come in and just let the thing expand and do kind of a radial cut. With something like this, you could go down into a bore and cut an O-ring. So you could dive and then expand and come out and do an O-ring or a snap ring groove. Boring, you can change diameters on the fly. If you're hogging, you know, you could really, you know, every time you use a regular boring head, you got to stop the machine, loosen the gibs, change the boring head, whatever. This, you can do it on the fly with it running, which is pretty cool. But let's try a little face fly cutting with it and see how we do. Okay, well, we got it set up. We're taking a 10,000th step to cut. We're getting these little springs off of there. We're using inserted carbide. It's a lathe tool, just a standard turning tool, facing straight down. We've got the cutter adjusted, you know, where we want it. I wanted to make a 4-inch cutter. You can see on midpoint here, you use your tool holder as a rough adjustment, and you can dial it in here and get it at any diameter you want, which is kind of cool. What I'm looking at now is my mill head is trammed, but I don't know whether when I bolted the Boremate on, whether that affected, you know, the tilt of the head. I'm getting a little slight back cut back here on this backside, so that tells me it's dragging on the way by. But we're going to cut the other direction and see what it does. You know, right now I'm running 400 RPM, and then up here you can see I'm running about just a little over 3 inches per minute. But it's mowing right along. It's doing okay. You know, you know what? It's single point cutting, and I need to keep my tool pressure down. I'm only doing 10,000th step to cut. As you can see, I'm working on a mag plate. And I've got my parts packed in there with that white sheet metal, so they're packed in. They're up against a fence in the back to keep them from slipping around with the tool pressures. I don't worry about them detaching from the mag and flying around, but they do like to slide around. So That's why they're packed in there with the sheet metal. And right now we're getting a back cut. You can see the back cut on this side of the tool. My next pass, I'm going to go across the other way and see what it looks like. And that's my preferred direction anyways, because what it does is the tool pressure is going to push the part into that rear fence, instead of right now it's trying to actually pull it away. But tool pressures are low, the carbide is sharp, life is good. Let me get going the other direction, I'll bring you back. We'll take a look and see if we've got a back cut in that direction and see whether this Boremate threw off our tram. So we're back at it, now we're heading the other direction. And what I'm looking for now is I'm looking for a drag on the right side over here, over, to the right side of the machine. And I'm seeing one, I'm starting to see a little bit of a drag. So I think we're still pretty square. I'm getting a back cut in both directions, which I find interesting. And that could be the spindle bearings in the Boremate. I don't know whether we're getting a little bit of up and down movement on there, and when the tool pressure comes off, it starts dragging the backside. But you can definitely see a drag on the backside of the cut. So it's doing that in both directions. So the Boremate didn't really affect the tram of the machine. My head was trammed on this less than a week ago, and I got it very close, within a few tenths. So pretty happy with this thing so far. It's just kind of mowing along there. And the cutter's performing very well. It's a Valinite little lathe tool, inserted carbide, triangular. When I shut it down, I'll show it to you. Okay, so what I've got is just a piece of steel. It's just a piece of 836 magged down to the plate. I'm not too worried about it moving around. I got a lot of surface area there. But I'm going to bring my quill down just till I get full contact on a perimeter. As so. I'm going to unlock here and crank out a little bit. And basically I'm just making a radial cut. And this is a lot like manually feeding on a lathe. Coming up on the end of it. That clackety clack you heard was me exiting the part over on the backside. Let's take a look at that. Yeah, that's where I was exiting over here. But pretty nice for work that you couldn't get in the lathe. Look at that, I just did a face. And the other advantage that I can think of with this is if you went down on a bore, if you could actually use this to touch off, much like you would a lathe. If you had a bore and then you had to get a snap ring groove or an O-ring groove down in a bore somewhere on a piece where you can't get it in a lathe, or it's difficult to get in a lathe, some weird casting or something, but you could drop down into a bore. Touch off with your tool, much the same way you would with on a lathe. Go down in the bore, and go down and plunge out, make your O-ring or snap ring groove, retract, and get out of that bore, and that'd be pretty cool. So any other way would not be possible without this thing. So there's the tool we've been using today. It's just a simple lathe tool, inserted carbide. It's a Valinite. Okay. All right, so pretty cool. Thought I'd demonstrate that. That's the Boremate. Not sure if they're made anymore. It's by Smith Associates in San Carlos, California. I don't know, maybe look them up on eBay. Maybe you can get your hands on one. Pretty nice. After it's installed and set up, it's actually a dream. Getting it set up, it's a little cumbersome, a little time consuming. Well, yeah, you need to take it apart in a very specific order. Remember, you're going to need a thin wall deep socket to even get to the drawbar. You have to take the quill all the way up until it stops. The borite stops it from going all the way up. So you're a good ½ inch short, and your drawbar is barely accessible. Now, you can crack the drawbar loose without worrying about dropping the Boremate, because remember, it's still clamped to the quill down here. But you can set your brake and cut loose your drawbar. You're going to have to make sure that drawbar is all the way out, because when you release this, you don't want to be fighting that drawbar at the same time. So, yeah, just spin your socket by hand. And put your fingers on it, make sure it's completely loose. And at that point, we can undo the clamp here to the quill and drop the whole thing out. And it's probably a good idea. I've already pulled my tool out. Make sure you pull your tool out. If you do drop it, it's going to, you're going to not break your carbide or whatever. Probably wouldn't hurt to have a block of wood down below either. Wow, it's seated even. We're going to have to give that drawbar a little tap, just like a regular tool. So it's seated all the way in. So it's got a really nice bearing, and what they tell you to do right here on the instructions is you fill the drawbar hole with oil, and that's what oils these bearings. And then it's got 2 pin oilers here for the gibs. All right, but that's the Boremate. Kind of a unique little tool. Glad I picked it up. You can get a better view of the tool holder here. You got a square tool holder on this side, and then over here they got a 5/8 round. So you can put just a plain round boring bar in it too. And then the center is the slider. There's a T-nut in here for your rough adjustments. Okay.